All right, so we didn't really have a video for this before class, but I'm gonna go over all the rules for factoring just to make sure that you guys really understood what we went over in small groups in class, or if you were absent. So the first one that I'm gonna do is the difference of two cubes. So cubes means that I have to the power of 3, but as we noticed in class, it doesn't actually have to say to the power of 3. I can change it to be to the power of 3. So what do I mean by that? Well, first I'm going to go over the rule. So difference is subtraction. So I have a cubed minus b cubed, and I factor it out as a minus b times a squared plus ab plus b squared. And this is the rule that I'm always going to follow, okay? After I do this, I'm almost always done. Every once in a while, I'll be able to factor this farther. I don't think any of the examples that I gave you guys, you were able to go farther here, but I could be wrong. So what happens is I have something like x cubed minus 8. 8 is not to the power of 3, but 8 is 2 to the power of 3. So that means that my a value is x and my b value is 2, and I just follow this rule. So a minus b is x minus 2. A squared is x squared, plus a times b is going to be x times 2, which is 2x, plus b squared is 2 times 2 is 4. And I'm done. Now sometimes it's a little bit more complicated, and it'll say something like this. So x to the 6. X to the 6 I have to turn into x squared to the power of 3. 125 is 5 to the power of 3. So on this one, my a is x squared. So it's going to be x squared minus, and my b is 5. X squared times x squared is x to the 4th, plus b times a is going to be 5x squared, plus 5 squared is going to be 25. And I'm dead. Now the really confusing one is when you have something like this. I have to make this into 2x to the power of 3 minus 5 to the power of 3. So that means that my a value is actually 2x. My b value is 5. So right here when I go a squared, it needs to be 2x times 2x. 2x times 2x is 4x squared. Plus b times a is going to be 10x. Plus b squared is going to be 25. Okay, that's the difference of two cubes. Now I'm going to do the sum of two cubes. Sum means addition. So that's when I have something like this, a cubed plus b cubed. This is going to become a plus b times a squared minus ab plus b squared. Now these ones go the exact same way as the difference of cubes. So if I have x cubed plus 125, that's the same thing as x cubed plus 5 cubed. So that's going to become x plus 5. X squared minus 5 times x is just 5x plus 25. So it follows the exact same rules. The other handout that we have quadratic like problems. So when I'm checking if it's a quadratic like problem, what I need to see is the first exponent twice as big as the second exponent, and the third one doesn't have an exponent. So what we had before is x squared plus x plus 1. This exponent is twice as big as this one, and this one doesn't have a variable. So that's a quadratic. It's to the power of 2, so it is a quadratic. We have other problems that are quadratic like, meaning that it goes something like x squared plus x to the 3rd plus 1. So this is twice as big as this one, and there's no variable here. So this follows the same rules for factoring and finding the roots as a quadratic would. The only thing is here I look for two things that would multiply to 1 and add to 1. Well, let's make that 2 so it actually works. Multiply to 1 and add to 2, which is going to be 1 and 1, and I would go x plus 1. And this one would be x plus 1. And the reason that it's x here is that's 1/2 of this exponent. So on this one, I would do the same thing. Two things that multiply to 1 and add to 2 which is going to be 1 and 1. But because I need two things, I need 1/2 of this exponent. It's going to be x cubed plus 1 and x cubed plus 1. So on these ones, that's what I mean by quadratic like. We follow the same process. Now we're not always done when we do that. For example, this is the sum of two cubes. This would become x plus 1 times x squared minus x plus 1. This one would also become that, x plus 1 times x squared minus x plus 1. And I'm doing that from the other part of the video, the sum of two cubes that I already showed you. So that's what we're doing here. We're trying to factor it as far as possible, okay? Quadratic-like problems, let's say that I have something like, I don't have any good examples. 3x squared plus 3x to the 12 plus 10x to the 6 plus 3. So if I was going to factor this one out, I would use the box method, but that's just me. Instead of using the box method, I'm going to show you guys something that makes probably more sense to you. Is your quadratic formula. Negative b plus or minus b squared minus 4ac over 2a. And remember that normally it's x equals this, but normally our middle term is x. So on this one, it's really going to be x to the 6 equals this. And I'm going to go through the process. X to the 6 equals negative 10 plus or minus square root of 10 squared minus 4 times 3 times 3 over 2 times 3. Negative 10 plus or minus the square root of 100 minus 36 over 6. Negative 10 plus or minus the square root of 64 over 6. Negative, I'm off the screen. Negative 10 plus or minus 8 over 6. Negative 18 over 6 and 2 over 6. Negative 18 over 6 is negative 3. 2 over 6 is 1/3. So these are the roots. If I want to actually have the factors, I normally would be x minus the root and x minus the root, because we get two of them when we use the quadratic formula. So that's what I would normally do. However, I'm not finding x. I'm finding x to the 6. So I would put x to the 6 here and x to the 6 here. So it's going to be x to the 6 minus negative 3, x to the 6 minus 1/3. When we have a fraction, the denominator comes to the front. So it's going to be x to the 6 plus 3 and 3x to the 6 minus 1. And if I distributed this out, it would get me back to this original expression that I had. So that's how we're going to factor those guys. The only other one that I have is very similar for quadratics. It's just multi-step stuff. So you'll have something like x to the 4 minus 16, which becomes, this is the difference of two squares. It's x squared minus 4, sorry. X squared plus 4. Now there's not a rule for the sum of two squares, so that's not going to change. But this is the difference of two squares, so it's going to become x minus 2, x plus 2. We just want to make sure that we factor all the way. And that's it.